Assessment of Naval Warfare Evolution by 2028, The Rise of Drones and AI Integration.
Introduction. The landscape of naval warfare is undergoing a monumental transformation driven by advancements in technology and strategic imperatives.
By 2028, expert analysts predict a 50% increase in the utilization of drones within combat operations, a trend significantly influenced by the strategic maneuvers of groups such as the Fujian. This report synthesizes key developments, challenges, and predictions regarding the evolution of naval warfare, highlighting the critical role of artificial intelligence (AI) and unmanned systems.
Key developments and predictions. 1. Integration of autonomous systems.
The U.S. Navy is at the forefront of integrating robotic and autonomous systems into its operational framework.
Admiral Lisa M. Franchetti in the Navy's 2024 Navigation Plan emphasizes the necessity of enhancing fleet readiness by 2027.
This plan focuses on the incorporation of larger robotic systems and AI applications,
which are essential for improving situational awareness in increasingly complex battle environments.
The integration of autonomous systems is not merely a tactical enhancement but a strategic imperative to counter mounting global threats, particularly from China.
2. Technological initiatives.
The Pentagon's Replicator initiative aims to expedite the integration of commercial unmanned technologies into military operations. This initiative reflects a broader commitment to harnessing cutting-edge technologies to bolster naval capabilities. The establishment of the Disruptive Capabilities Office by Navy Secretary Carlos del Toro signals an intent to invest in and scale innovative hardware and software solutions. Additionally, dedicated task forces such as Task Group 59.1 and Task Force Hopper focus on developing unmanned capabilities and AI/machine learning (ML) technologies,
respectively. 3. Collaborative partnerships.
The Navy is forging collaborative partnerships with the Defense Innovation Unit (DIU) and various technology vendors to operationalize AI across diverse naval operations. These partnerships aim to enhance underwater threat detection and improve sensor and munitions management. Projects like AMMO, which focuses on developing machine learning tools for underwater operations, exemplify this collaborative approach.
4. Challenges and limitations.
Despite these advancements, significant challenges remain.
The Navy's traditional focus on larger military assets such as aircraft carriers often deprioritizes digital capabilities.
Reports indicate that the Navy allocates the least funding to emerging defense technology firms compared to other military branches, potentially hindering technological innovation. Furthermore, the bureaucratic nature of the Navy can slow the adoption of new technologies with lengthy accreditation processes for integrating software onto ships. 5. Counter-drone strategies. As drone threats escalate, the Navy is actively exploring cost-effective solutions to counter adversarial unmanned systems.
The focus on directed energy weapons and counter-drone systems illustrates a proactive approach to addressing these emerging threats.
This strategic shift is crucial as the Navy seeks to develop more economical methods to neutralize low-cost drone threats which can pose significant risks to naval operations.
Timeline of events.
September 2023, release of the Navy's 2024 Navigation Plan emphasizing the need for faster integration of AI and unmanned systems.
2023, announcement of the Replicator initiative to accelerate the adoption of unmanned capabilities across military operations.
March 2024, conduct of the Naval Applications of Machine Learning (NAML) workshop showcasing various AI or ML applications in naval operations.
Common themes
across various sources. Several common themes emerge regarding the future of naval warfare. AI and unmanned systems. There is a consensus on the critical importance of AI and unmanned systems in shaping the future of naval combat. Agility and innovation. Recognizing the need for agility, the Navy is urged to foster an environment conducive to rapid innovation and adaptation. Institutional challenges. the traditional structures within the Navy present challenges to embracing new technologies and methodologies.
Differences in perspectives.
While there is agreement on the significance of AI and unmanned systems, perspectives diverge on the pace of adoption and the Navy's willingness to embrace transformative change. Some analysts highlight the Navy's historical resistance to disruption, while others emphasize ongoing collaborative efforts to bridge the technological gap. This divergence underscores the complex interplay between tradition and innovation within the naval service. Conclusion. The evolution of naval warfare by 2028 will be characterized by an increased reliance on drones and autonomous systems driven by technological innovation and strategic imperatives. However, the Navy must navigate the challenges posed by traditional military practices and funding constraints to fully realize the potential of these advancements. As the strategic environment continues to evolve, the integration of AI and unmanned systems will be critical in ensuring that naval forces remain effective and responsive to emerging threats.
The path forward will require a commitment to innovation, collaboration, and a willingness to embrace change in a rapidly evolving landscape.
The content presents several counterintuitive insights regarding the evolution of naval warfare and the expected increased utilization of drones by 2028. 1. Resistance to change. Despite the clear strategic imperative for integrating drones and AI into naval warfare, there is a pronounced historical resistance within the Navy to embrace disruptive technologies.
This contrasts with the urgent need to adapt to emerging threats, particularly from China and other adversaries.
Analysts expect a 50% increase in drone utilization, yet the Navy's traditional focus on large assets such as aircraft carriers often deprioritizes digital innovations. This juxtaposition raises questions about the Navy's ability to effectively integrate new technologies while adhering to established practices that may hinder rapid adaptation. 2. Budget allocation paradox. The Navy allocates less funding to newer defense technology firms compared to other military branches,
despite the pressing need for innovative solutions.
It is surprising that while the overall defense budget is substantial, a significant portion goes to established companies like SpaceX, leaving emerging tech firms with only a fraction of the funding. This reliance on traditional contractors may impede the Navy's ability to swiftly adopt cutting-edge technologies that are critical for future warfare. 3. Cost-effectiveness dilemma. The Navy faces a critical challenge in countering drone threats, particularly small, inexpensive drones. It is counterintuitive that high-cost solutions like $1 million missiles are used to defeat lower-cost threats like $100,000 drones. This mismatch in expenditure highlights a potential inefficiency in resource allocation and strategic planning, suggesting that the Navy may be overlooking more cost-effective counter-drone strategies. For AI integration complexity. While there is a strong push to integrate AI into naval operations, the complexity involved in getting this technology onto ships poses a significant barrier. The necessity of an accreditation process for software to be deployed on naval vessels can slow down the implementation of AI, which contrasts sharply with the urgent need for rapid technological advancement.
This complexity could lead to delays in operational readiness, undermining the Navy's strategic goals.
5. Collaborative innovation versus traditional structures. The Navy's efforts to foster partnerships with tech companies through initiatives like the Defense Innovation Unit (DIU) and the Replicator initiative are laudable. However, the traditional structure of the Navy may complicate these collaborative efforts. The expectation that a legacy organization can pivot to embrace innovative commercial technologies at a rapid pace may not align with the inherent bureaucratic challenges faced by military institutions.
6. Evolving threat landscape. The acknowledgement that adversaries are adapting quickly is seen with Russia's response to Ukrainian innovations. Contrasts with the Navy's slower pace in adopting new technologies.
This highlights a potential strategic gap where adversaries may outpace the Navy in technological advancements, further complicating the efficacy of naval operations in an evolving threat environment. In summary, the content reveals a tension between the need for rapid technological adaptation in naval warfare and the structural, financial, and cultural challenges that the Navy faces in implementing these changes. The counterintuitive insights underscore the complexities of modern military operations, where the urgency for innovation must be balanced against traditional practices and budgetary constraints.
Important overlooked content in the report on naval warfare evolution by 2028. 1. Potential of collaborative AI systems.
While many reports emphasize the integration of AI in naval operations,
the potential of collaborative AI systems is often understated.
The Navy's ability to harness AI not just for individual units but as a cohesive system across multiple platforms can significantly enhance operational effectiveness. For instance, AI could facilitate real-time data sharing among ships and drones, creating a unified operational picture.
This is crucial in a combat environment where rapid decision-making is vital.
The collaborative approach could also mitigate the traditional silos within military branches, promoting a more integrated force. Significance: emphasizing collaborative AI could lead to more innovative strategies in naval warfare, improving responsiveness and adaptability in real-time scenarios and ultimately providing a tactical advantage over adversaries who may not have such integrated systems.
2. Importance of counter-drone strategies.
The report mentions the rising threat of drones. Yet the depth of analysis on counter-drone technologies is often superficial. The Navy's exploration of directed energy weapons and other counter-drone systems is a critical component of modern naval warfare that warrants further attention. Understanding the specific technologies being tested, their deployment timelines, and effectiveness can provide insight into the Navy's preparedness against asymmetrical threats. Significance: as drone technology evolves, so do the tactics needed to counter them. A robust counter-drone strategy not only protects naval assets but also influences broader strategic outcomes in conflicts where drone warfare is prevalent.
3. Funding discrepancies among military branches.
The report highlights that the Navy allocates the least funding to newer defense technology firms compared to other military branches.
This funding discrepancy is significant as it suggests a potential technological gap that could hinder the Navy's operational capabilities.
The reliance on traditional military assets and the lag in adopting innovative technologies could pose a strategic disadvantage.
Significance: addressing this funding issue is paramount for the Navy's future capabilities.
A shift in funding priorities towards emerging tech firms could stimulate innovation and bring in fresh perspectives that align with the evolving nature of warfare. 4. Cultural resistance to change. The Navy's historical resistance to disruption and reluctance to fully embrace digital transformation is a critical aspect often overlooked. This cultural inertia can significantly delay the integration of necessary technologies, impacting fleet readiness and global operational effectiveness. The acknowledgement that change is hard in the naval service underscores a systemic issue that transcends technical challenges. Significance: understanding and addressing cultural resistance is essential for successful technology adoption. Initiatives aimed at fostering a culture of innovation within the Navy could facilitate smoother transitions to new technologies and operational paradigms.
5. Strategic implications of AI and robotics.
The report mentions the strategic imperative of integrating AI and unmanned systems but does not delve into the broader strategic implications of these technologies on global naval power dynamics. The increased use of drones and autonomous systems could shift the balance of power, particularly in contested regions like the South China Sea. The implications of these technologies on deterrence strategies, alliances, and adversarial behavior are crucial considerations that deserve more focus. Significance: a comprehensive understanding of how AI and robotics reshape strategic landscapes can inform policy decisions and military strategies, ensuring that they align with the realities of modern warfare. 6. Impact of AI on supply chain management. The report briefly touches on the role of AI in improving defense manufacturing and supply chain management but fails to explore the transformative potential of AI in logistics.
Efficient logistics are vital for operational success, especially in maritime operations where supply lines can be vulnerable.
Significance: leveraging AI for enhanced logistics could lead to more efficient resourcing, better maintenance schedules, and improved readiness. This aspect can significantly influence the operational capabilities of naval forces.
7. Evolving nature of threats.
While the report highlights the focus on counter-drone technologies, it overlooks the evolving nature of threats in maritime environments, such as cyber warfare and hybrid threats. The integration of AI into cyber defense strategies and the potential for drones to be used as vectors for cyber attacks are areas that warrant deeper analysis. Significance: a multifaceted approach to threat analysis that includes cyber capabilities will better prepare naval forces for the complexities of modern warfare, where threats are not only kinetic but also digital.
8. Operationalizing AI in undersea warfare.
The report mentions partnerships aimed at enhancing underwater threat detection but does not fully explore the potential of AI in undersea warfare. The strategic importance of submarines and underwater drones in future naval conflicts is becoming increasingly critical, yet the operationalization of AI in this domain is often underrepresented. Significance: emphasizing AI's role in undersea warfare can lead to advancements in stealth detection and engagement capabilities,
crucial for maintaining naval superiority. 9. International collaboration and competition.
The report primarily focuses on U.S. Navy initiatives without adequately addressing the international landscape of naval warfare, particularly how other nations are adopting similar technologies. The pace at which countries like China and Russia are integrating AI and unmanned systems into their naval strategies could influence U.S. military planning and resource allocation. Significance: understanding global trends in naval warfare technology can inform U.S. strategies, ensuring they remain competitive and responsive to emerging threats.
10. The role of industry partnerships in innovation.
The emphasis on industry partnerships in developing new technologies is significant, however. The report does not thoroughly analyze how these partnerships can be structured to ensure rapid innovation and effective integration of new capabilities into existing platforms. Significance: developing a robust framework for industry collaboration can facilitate faster technological advancements and ensure that the Navy can swiftly adapt to changing threats and operational requirements.
Conclusion:
the evolution of naval warfare by 2028 is an intricate interplay of technology, strategy, and cultural dynamics within the U.S. Navy. While the report outlines key developments, the overlooked aspects highlighted above are crucial for understanding the full scope of challenges and opportunities that lie ahead.
Addressing these elements is vital for the Navy to maintain its strategic edge in an increasingly complex global security environment.
1. Integration of autonomous systems. The shift towards integrating autonomous systems and AI in naval operations is pivotal. The U.S. Navy, is highlighted by Admiral Lisa M. Franchetti, is focusing on enhancing fleet readiness through the adoption of robotic and autonomous systems.
This is crucial in addressing global security challenges and countering threats from nations like China.
The emphasis on larger robotic systems and AI applications for improved situational awareness reflects a strategic pivot that could significantly alter naval combat dynamics by 2028. 2. Technological initiatives and the Replicator initiative. The Pentagon's Replicator initiative is a key development aimed at expediting the integration of commercial unmanned technologies into military operations. This initiative, alongside the establishment of the Disruptive Capabilities Office, demonstrates a concerted effort to scale innovative solutions within the Navy. The focus on cutting-edge hardware and software, including machine learning for underwater threat detection, positions the Navy to leverage emerging technologies more effectively in future combat scenarios. 3. Collaborative partnerships and technological advancements. The Navy's collaborations with the Defense Innovation Unit and tech vendors to develop AI and machine learning tools are vital for operationalizing these technologies in naval warfare. These partnerships not only enhance capabilities for sensor and munitions management but also address the need for agility in adapting to new threats and operational environments. The focus on operationalizing AI across diverse naval operations underscores the importance of innovation and cross-sector collaboration in modernizing naval warfare. 4. Challenges and limitations in technological adoption. Despite advancements, the Navy faces significant challenges in rapidly adopting new technologies, primarily due to a historical focus on traditional military assets. The allocation of funding reveals a reluctance to invest in newer defense technology firms, which could hinder technological innovation and adaptation. This resistance to change, coupled with the Navy's existing infrastructure and budget constraints, poses risks in maintaining competitive advantage in an evolving warfare landscape characterized by increased drone utilization and autonomous systems. 1. The Battle of Jutland 1916. This naval battle during World War I was a significant confrontation between the British Royal Navy's Grand Fleet and the Imperial German Navy's High Seas Fleet. While the battle itself was not directly influenced by drone technology, it marked a pivotal moment in naval warfare, showcasing the importance of technology and tactics. The battle involved the use of various naval vessels, and the lessons learned about the use of intelligence and reconnaissance would later influence the development of modern naval strategies, including those that might incorporate unmanned systems. 2. The Falklands War in 1982. This conflict between Argentina and the United Kingdom over the disputed Falkland Islands highlighted the evolving nature of naval warfare, particularly the strategic use of air power and naval assets. The British successfully utilized aircraft carriers and submarines, demonstrating the importance of integrating different types of warfare, including aerial and maritime operations. The introduction of Exocet missiles by Argentina and the subsequent British countermeasures can be seen as a precursor to the modern integration of drone technology in naval operations, where unmanned systems could be employed for reconnaissance, targeting, and strike missions. 3. Operation Desert Storm 1991. The Gulf War showcased the transformative impact of technology on warfare, particularly the use of precision-guided munitions and advanced reconnaissance capabilities. The success of naval forces, including the use of Tomahawk cruise missiles launched from submarines and surface ships, underscored the effectiveness of integrating various technological advancements in naval combat. This operation set the stage for future conflicts where unmanned systems similar to drones would play an increasingly critical role in gathering intelligence, executing strikes, and supporting naval operations, influencing predictions about their future utilization in naval warfare by 2028. By 2028, naval warfare is poised for a transformative evolution driven by technological advancements, particularly in unmanned systems and artificial intelligence (AI). Analysts predict a 50% increase in drone utilization in combat operations, significantly influenced by strategic frameworks such as those employed by the Fujian Group. Here we examine the key developments, challenges, and future outlook for naval warfare. Key developments. 1. Enhanced integration of autonomous systems. The U.S. Navy, under the leadership of figures like Admiral Lisa M. Franchetti, is prioritizing the integration of robotic and autonomous systems. This shift aims to improve fleet readiness and operational capabilities, particularly in response to rising geopolitical tensions with China. The Navy's 2024 navigation plan emphasizes the need for larger robotic systems and AI applications to enhance situational awareness and combat effectiveness. 2. Technological initiatives and military partnerships. The Pentagon's Replicator initiative represents a significant push to accelerate the incorporation of commercial unmanned technologies into military operations. By streamlining procedures and fostering collaboration with tech firms, the initiative aims to enhance the Navy's capabilities in various domains. Additionally, the establishment of specialized task groups focused on unmanned systems and AI will drive innovation and operationalization of these technologies. 3. Collaborative innovation. Partnerships between the Navy and organizations like the Defense Innovation Unit (DIU) are central to developing machine learning tools and enhancing operational efficiency.
These collaborations aim to utilize AI in threat detection and sensor management, fostering a more agile and effective naval force.
4. Counter-drone strategies, as drone warfare escalates. The Navy is actively exploring cost-effective counter-drone solutions. Recent efforts include the development of directed energy weapons and advanced counter-drone systems to neutralize threats posed by adversarial unmanned systems.
Challenges and limitations.
Despite technological advancements, the Navy faces significant challenges, particularly in rapidly adopting new technologies.
The traditional focus on larger assets such as aircraft carriers often sidelines digital capabilities.
Reports indicate that the Navy allocates the least funding to new defense technology firms compared to other military branches, potentially hindering innovation.
Moreover, the Navy's established culture can be resistant to change, complicating efforts to integrate new technologies efficiently.
The bureaucratic processes required to incorporate software and AI into existing systems can also delay the adoption of crucial innovations.
Future outlook.
1. Increased reliance on drones and autonomous systems. By 2028, drones and unmanned systems are expected to play a central role in naval operations, enhancing situational awareness,
combat capabilities, and logistical support. The anticipated 50% increase in drone usage will likely redefine engagement strategies and operational dynamics.
2. AI-driven decision-making. The integration of AI technologies will enable more effective decision-making processes in complex combat environments. Enhanced data analytics and machine learning applications will provide commanders with real-time insights, improving tactical responses and operational planning. 3. Evolving maritime strategies. As the naval landscape becomes increasingly contested, strategies will evolve to address the unique challenges posed by unmanned systems. This includes comprehensive counter-drone capabilities and new operational doctrines that leverage the strengths of AI and autonomous systems. 4. Collaborative defense ecosystem. The future of naval warfare will hinge on fostering a collaborative ecosystem between military and private sectors. By bridging the gap between defense and technology firms, the Navy can accelerate innovation and enhance its technological edge in maritime operations. 5. Investment in emerging technologies. To maintain competitiveness, the Navy must prioritize investments in new technologies, particularly those developed by small and innovative firms. A shift in budget allocation towards digital capabilities and AI will be essential for ensuring future success.
Conclusion.
The landscape of naval warfare by 2028 will be characterized by a pronounced shift toward the integration of drones and AI systems, significantly altering operational strategies and engagement paradigms.
While challenges remain in terms of cultural resistance and budget allocations, the ongoing initiatives and collaborative efforts signal a commitment to embracing innovation. The successful adaptation to these changes will be crucial in navigating the complexities of future maritime conflicts and ensuring strategic advantages on the high seas.